Configuring and applying standard access control lists. That title says it all. Let's get started. You might remember me saying in the previous nugget that the only way to get access lists down is by doing them again and again and again. It's like subnetting. So that's what I've done here, is created a scenario of standard access lists in this case that we're going to work through. But before we dive right in, I want to go through and just familiarize ourselves with this whole network diagram. First off, left-hand side, you can see we've got the 192.168.1 network. So we've got a computer on there, 192.168.1.50. Default gateway is 1.1. And then we've got a WAN link. Now we've gone to a /30 subnet mask on here. So again, practicing our subnetting skills, sometimes you're going to look at that and say, okay, well, what is that range? What IP addresses are in there? Now, in this case, it's easy, especially if you have experience looking at a /30, because you know there's only two IPs and they're assigned on each side. But let's say you didn't. What you would do is say, okay, well, /30 as a decimal subnet mask, what is that? Convert that back to decimal. So that would be a 255.255.255.252. Now, some of you might say, well, how'd you know that? Well, it's just because I know. But when you take 30, essentially that means there's 30 ones in the subnet mask. So that's 8 ones, 8 ones, 8 ones, 6 ones right there. So add them all up. And there's your 30. So that will be where you get the 252, is by putting your 6 ones, that's 6, like that. Now, the good news is that also gives you your increment. Remember, lowest network bit as a decimal is a 4. So I'm going to be able to reverse engineer my ranges. They would have had to start at 10.1.1.0, .4, .8, .12, you know, down they go. So fill in the end ranges. And now I've, not written that right. Now I've reverse engineered what we've got here. So this one is 10.1.1.0 through 3. Can't use 0, it's a network. Can't use 3, it's a broadcast. So 1 and 2 are the usable IP addresses from there, right? So that explains our WAN links. So our WAN links are being very efficient. We're actually using VLSM in this scenario, variable length subnet mask, changing the subnet mask based on the fit. So what's up with this? Well, I put this on there, this /25 at both of these locations, because you will run into that subnet mask in the real world. A lot of people use it. It's very efficient. But also because I really want to show you how wildcard masks work, which is what ACLs really thrive on. So seeing this, you might say, okay, well, explain that to me. How do we do that? Well, same thing. A /25 is really 255.255.255. That's 8 plus 8 plus 8. That's 24 ones so far we've got. So 25 ones would be 128, right? So essentially 1000000 is what that comes out to. So